When a synchronized amber flash pulses across an enterprise server rack, it usually signals the initiation of a high-stakes system process. In a large-scale network, modifying a single configuration is never an isolated technical task. Because systems are deeply interconnected, any modification represents a significant organizational risk. Technicians who implement undocumented or unapproved fixes introduce operational liabilities. Without oversight, a minor change in one sector can trigger a cascade that leads to total network failure. This diagram illustrates the change and inventory management cycle, the defensive architecture necessary to identify and mitigate cascading failures. It ensures every modification delivers business value without compromising existing services. We will examine its specific phases: change requests, risk analysis, board approvals, asset management, and warranty parameters. Adopting this structured administrative model ensures that system modifications are treated as controlled deployments rather than reactive troubleshooting. Formal system alterations begin with a proposal to modify a specific configuration before any physical hardware is swapped or code is deployed. This slide defines the change request. This form acts as the foundational document that initiates the process and establishes a record of the proposed change. The request documents the baseline reason for the modification. The change description and change reason fields identify if the goal is an upgrade, a bug fix, or the rollout of a new feature. By requiring an entry in the impact of change section, the process forces a technical evaluation of how the modification might affect the rest of the network. This section translates technical actions into business metrics, requiring the technician to account for the impact on the budget, total cost, and the implementation schedule. Common examples include submitting a request for a major server OS update or adding new hardware to a networking stack. This form creates the audit trail required to understand exactly why a system configuration was altered months or years after the fact. After a technician submits the request, the document is routed to a governing committee for review. This infographic outlines the role of the Change Advisory Board, or SAB. This team is responsible for reviewing and authorizing significant system changes. Based on this analysis, the CAB has the authority to approve the request, deny it, or defer the implementation to a later date. This review process ensures that necessary technological improvements do not compromise the security or availability of core IT services. To make these decisions, the CAB requires objective data about the current state of the network. This data is provided through asset management. This slide defines an IT asset as any hardware, software, license, or resource owned by the organization. Tracking these assets supports the entire lifecycle of the equipment and aids in mandatory security audits. The breakdown on the right distinguishes between physical assets, like servers and peripherals, and digital assets, such as software licenses and virtual machines. Physical assets are tracked using tags. Organizations choose between standard identification numbers or barcodes to facilitate rapid auditing. Every asset receives a unique ID. Using a consistent system with standard barcodes, like Code 128, helps prevent human error during inventory checks. This slide shows the data points associated with that unique ID. A complete inventory record includes the manufacturer, exact model, and technical specifications. For risk assessment, the CAB also needs the physical location and assigned user. This data is stored in a configuration management database, or CMDB. While small environments might use spreadsheets, enterprise networks rely on these databases to track complex systems. A CMDB maps the relationships between assets. This allows the CAB to see, for example, exactly which servers rely on a specific network switch before they authorize an upgrade. Without an accurate, updated CMDB, the advisory board cannot effectively predict the cascading outcome of a high-risk change. Once a change is authorized and the impact is mapped, the technician can begin execution, though they must still observe specific external constraints. This slide identifies vendor warranty and licensing as the final checkpoint. These parameters dictate how physical repairs and replacements are handled. Technicians must first determine if the vendor covers the cost of the repair or the replacement parts under an existing agreement. The matrix shows baseline coverage varies significantly by manufacturer, typically ranging from 90 days to 3 years. Knowing which actions are permitted is critical. Unauthorized physical work or hardware upgrades can accidentally void a warranty, leading to unexpected costs. Maintaining precise documentation during the repair is required to ensure the vendor honors any future service claims. For example, verifying that a laptop is under a 3-year service contract allows the department to utilize vendor support instead of paying for a new replacement. Understanding these legal parameters protects the organization's budget and ensures that daily repair workflows remain fully compliant with strict vendor requirements. This diagram shows that enterprise IT governance functions as a continuous, interconnected feedback loop. The cycle begins when a technician submits a formal change request to document the intent and logic of a modification. That request undergoes risk analysis and requires board approvals from the CAB to maintain organizational stability. The CAB relies on granular tracking data from asset management to understand how the change will impact the broader network. Finally, the physical implementation is guided by warranty and licensing parameters to ensure financial and operational compliance. These administrative procedures provide the exact structure necessary to prevent isolated technical changes from causing systemic, cascading network failures. Consistently applying these controls enables an IT department to maintain predictable uptime as the number of managed devices and software licenses grows. Mastering the change and inventory management cycle ensures that IT professionals deliver system updates with accountability, efficiency, and minimal risk.